Hi guys, I'm Howdy. You may know the free space method for material test in my previous video. Today, I will show you the waveguide transmission line method to characterize the material's permittivity and permeability. This method uses an enclosed rectangular waveguide as the transmission line. The machined rectangular material is inserted into the waveguide, and the VNA can measure the reflected and transmitted signals. And the software can calculate the expected permittivity and permeability parameters. This is the typical setups for this method. The fixture part contains two coaxial waveguide adapters and the waveguide transmission line, the high-performance vector network analyzer, and the computer containing the analyzing software. Different frequencies need different waveguide, so the material should be machined according to the different waveguide size. This is a typical waveguide calibration case for VNA. This 4 GHz to 6 GHz calibration case contains two coaxial waveguide adapters, two short sheets, two load, and two 1/4 lambda wavelength offset waveguide. On one hand, the calibration kit can help to calibrate the VNA, and on the other hand, each 1/4 wavelength offset can be used as the transmission line. So normally, this method needs a series of calibration kits for banded frequency coverage. After choosing the proper method and select the frequency in the software, we follow the calibration wizard to make a typical SLOT calibration. Then we input the material, a piece of material of PTFE, into one end of the waveguide, and then insert the transmission line between the two adapters. The thickness of this 1/4 wavelength offset is 20 mm. The material's thickness is about 2.96 mm. So we input the value A, 17.04 mm, B, 0, and D, 2.96 mm into the panel, and press Start Measure button. We can see from screen that the dielectric constant is about 2.0 from 4 GHz to 6 GHz. It is a widely accepted value for PTFE. Now we can use another smaller transmission line to make a 26.5 GHz to 40 GHz test. We use this calibration kit to make VNA calibration and also use each 1/4 wavelength offset waveguide to hold the material and test. Firstly, we follow the calibration wizard to make a short offset through calibration. We insert the small piece of material into the offset sheet and input the A, 0 mm, B, 1 mm, and D, 2 mm on computers. After pressing the Start Menu button, we can get the result shown on screen. The permittivity is also around 2.0 from 26 GHz to